Hello everyone. Hello. So very few students joined today. Some of them have exam. But anyway, this video recording will be there. So let me check one more thing. Okay, like this is fine. Yes, yes. Okay. So, okay, before starting this lecture today, I will ask you something from the previous two labs. So we did, today we will do frequency modulation. Previously we were doing amplitude modulation. Okay. So what was our process? This frequency is, here we will be playing with the phase. But previously we were playing with the amplitude. Yes? Yes. So today is narrow band frequency modulation of topic. So this lab is about this. So the same things, what we do in modulation, we have one signal x of t, message xm of t, then we have xc of t carrier. Okay, we multiply them and then pass through the channel, and then at the receiver we filter it out, and then we just get this estimated signal of information. This is the modulation process. So we were doing it in the last two labs, lab 4 and 5. So same things, transmitter, first we will, so same thing, we generate the message, we modulate the message, then the modulated message is equals to message plus carrier multiplied by carrier, and then we have different type of modulation techniques. So today we will be studying frequency modulation. Okay, any idea what will happen in the frequency modulation? In amplitude modulation, amplitude of the carrier is varied according to the message signal. So what happens in frequency modulation? In frequency will vary. Yes. So you see, this is your message signal. Okay. Then this is your carrier. Okay. Then here, this is your modulated signal. Here you can see that frequency is varied. The amplitude is constant. The frequency is varied. Okay. What does it mean? Frequency is varied. It means that phase is changing. Phase is no more the same. Okay. So this is your carrier signal, AC cosine of omega c plus phi. This is the change in the phase. Okay. Then we can write this all thing as a theta, because cosine of theta. So theta is equals to omega c is equals to 2 pi fc here, right? And then into t. T is this one here, plus phi is equals to 2 pi kf into integral. So what happens here? We will pass this message signal. This is my message. We will pass this through a voltage controlled oscillator, which is used in modulation. In the next slide, I showed this. I will come back to it, but first I tell you this. Okay, so then this is my message signal that integrated over time. But what happens here? Actually, that is very high than me. This is my message. Okay. Then this is my carrier. Here, if this is positive, my frequency will be high. When this wave is negative, my frequency will be low. It means this area from 0 to t, this changes my carrier. According to this trend of increasing and decreasing trend of my message signal, my carrier signal will change from 0 to t. That's why I'm taking the index. Okay, my amplitude is not changing. Okay, then my modulated signal is AC cosine of this thing I put this theta here. Then I get this equation. AC cosine of 2 pi fc plus kf. Then now here, this is a constant kf. This is the frequency sensitivity. Okay. So voltage to frequency control ratio also this is known as. So how much sensitivity means how much variation in the carrier will occur due to this my message signal. This will be defined by kf. Okay. So then this
So this from T to T?
0 to T or T to 2T. Yes.
No, I mean the negative side won't affect the carrier.
It will affect, see, the positive side will affect in a way that the frequency will increase in the modulated signal. The negative will affect the frequency will decrease. Here, see, where this trend is negative, you see, the frequency is less here. But when the trend is high, the frequency is high here. This is high frequency, this is low frequency. It's visible from here. Whenever the phase is going up, frequency is high. Whenever it's lower, then frequency is low. Okay, so this way. Okay. So here, your modulated signal, this one, we're talking about this. Then integrator, then phase modulator. Here you will multiply it with the carrier, and then this is frequency modulated. Okay. First, you will pass your information through the integrator. This is voltage controlled oscillator. Now I will talk about the voltage control oscillator in this slide. This erasing is a bit difficult. So the voltage controlled oscillator is a device whose frequency changes linearly with an input voltage. So in this case, we have input information signal, that is our input signal. The frequency will change according to the input signal. It can be voltage, it can be your information signal, anything. Your frequency will change according to the input. Okay. So it is used to perform direct in frequency modulation voltage control oscillator. Okay, which is used to change the frequency according to the information, according to the message. So this was a small overview about it. So VCO, voltage control oscillator, has a center frequency Fc, and then input modulates the instantaneous frequency. What happens? This is your message. According to this, so what is instantaneous frequency? Instantaneous frequency is the frequency at any point. For example, this is my instantaneous frequency, maybe 20 hertz. At that instant and at time t1. At t1, my frequency is 20 hertz. So this is my instantaneous frequency, specific instant. So this modulates the instantaneous frequency around the center frequency. As a center frequency across which it will modulate the instantaneous frequency. This is, I think maybe in electronics you will study this hardware, but for the communication, this is a device which is used to change the frequency according to the input. Okay. So now, this is your signal which we had here. This one, modulated signal, is here. This is the general equation of frequency modulation. This equation you have to remember this. Okay. Then in narrow band frequency modulation, so what will happen here? How I got this is the general equation for frequency modulation, and then this is the general equation for narrow band frequency modulation. So what happens here? You know, here we will put the trigonometric identity. Cosine of alpha, this we can consider as alpha, and then this whole term as beta. Cosine of alpha is equal to, we will solve it. So this is equal to cosine of alpha or cosine of I think sine of beta plus cosine of, I think I don't remember the identity. So this identity you will use here, and then finally after solving you will get this equation. Okay, that solving part is not here. But after putting the trigonometric identity, you will get this.
Then who will do it with Misty?
With Miss Seema, I think she will cover it. But here for just telling you that this is the basic equation for frequency modulation. This is the basic equation for the narrow band frequency modulation. There is, so these mathematical equations, I think in the last, she told me today that last 2 weeks she will cover this. But she didn't do it yet. So then, what happens if you implement this equation here? How you will do it? First of all, this is my message here. Then this integrator. Then the product from here. This is my carrier. We have a phase shift. So when we integrate cosine, what we get? Sine. After integrating the cosine, we get sine. So we will get a phase shift here. This becomes sine of 2 pi fct. Then we multiply it with this constant 2 pi fc, 2 pi kf, and then this summer we will do the here subtraction and then this carrier here 2 pi fc, and then with amplitude at the end we will get s of t. Okay, so all this equation, this is implemented in this block diagram, and then this is the block diagram for narrow band frequency modulation, and this is the equation for it. Okay, fine. So then, so these are a bit more mathematics. So this is my equation for the carrier frequency, carrier signal. This I got in the first slide, the first equation. Now I have my message signal. Mi is equals to ai cosine of omega it. This we were doing in the previous 2 class. Then this phi m of t, you remember here. So this is the phase shift. Okay. So this phi is equals to k naught into integral of message signal into the differentiation. So this is my that phase shift. Okay. First, I will pass this message through the integrator, multiply with the frequency sensitivity. Then, after integration, this here I will put this here. Then I will get it. Then after the integration, this will convert to sine. Okay. Then after this simplification, this KFM into AI will become delta F. Delta F is the carrier frequency deviation. Okay. And then beta FM is the modulation index. Okay. So modulation index, what it does, how much variation, before we had the modulation index for the amplitude modulation, that how much variation in amplitude is happening. Here, this will tell us how much variation in the frequency is happening. Okay. This modulation index will tell that how much variation in frequency is happening. Okay. Then, actually, these equations are a bit difficult. You have to do a lot of mathematics for this. Then, finally, after solving, we will get this equation: AC cosine of omega c of t plus beta into Fm. So, where beta Fm is the modulation index. Okay. Then sine of omega I of t. So here omega c is equal to 2 by fc, and this is the information omega for the information signal 2 by fi. So actually, but how I got that equation? I put this in there, then in that equation, and then I get this modulated signal here. What I was doing in the amplitude modulation, I was just multiplying carrier with the message. But here, after solving all these equations, I got this final equation. I will not simply write x of t multiplied by carrier. I will write this whole equation in my head. First, I will write my message, then I will write my carrier, then I will write this modulated signal equation. Okay. So if for the narrow band frequency modulation, my modulation index should be less than 1. And for the wide band, there is only one difference between wide band frequency modulation and narrow band, that this modulation index is less than 1 in case of narrow band, and it is greater than 1 in case of wide band. Okay. So then, simple. Here, these are my variables. which I will use. So first is the frequency gain ratio, KFM. This is also known as frequency sensitivity. Then frequency deviation, KFM into AM. And this is the amplitude. Okay. Then modulation index. This we will define. All these variables we had in the previous equations. We derived from them. Then at this side, this is my message. This is my carrier, and this is my modulated signal, which I derived here. So three things here. We will plot these, and until here we will do the modulation. Then we will, at the receiving end, we will do the demodulation. So this is the scale 0, 1. Actually, I am not able to remove it. Okay. So this is the same scale 0 to 1, 1 divided by Fs. This is my sampling frequency, 4 divided by Fm. This is my cycles, and then Fm is the message signal. Same like previous. Then at the demodulation, very simple, we will use only this command to demodulate our signal. This x of t is the received signal here. This signal, the modulated signal, this is here. Then this is carrier frequency, this is sampling frequency, this is modulation method, this is frequency modulation. FM means frequency modulation, and then KFM is my voltage, my frequency sensitivity or voltage to gain ratio. So this is only one command for the demodulation. Okay. Then here, this is my received signal, which I showed you previously also. So this signal we will put here x of t, and then my estimated signal will come out after this command demodulation. So this is your example for today. So we will do the frequency modulation. So message signal frequency, message signal should be 5 cycle, and then carrier signal in time domain we will plot, transmitted signal in time domain we will plot, then estimated signal, that equation which I derived at the end. Then so noise is neglected, there is no noise. Then amplitude of message signal is 1, and then frequency is this. The carrier sinusoid is 1, and then frequency is 500. Sampling frequency is 10 kilohertz, and then KFM, voltage to frequency gain ratio, it's 350. So we will start our coding like this. First of all, we will define the carrier frequency, then message frequency, then sampling frequency, then time vector. This is my scale, because it was given in the question that I have to get 5 cycles. 5 divided by FM. FM is my frequency of message, which is 35. So up till 7 it will go. Then the amplitude of carrier. First my carrier, then message, then this voltage frequency sensitivity or voltage to frequency gain ratio. Then this is my frequency deviation, KFM into AM. Then this is my modulation index. Then this is my equation for the modulation. This is my modulated signal. So here also it's this. First message, then carrier, then my transmitted signal or modulated signal. Then I will plot all of these. And then the next step is only doing the demodulation. This command demod. Remove it. So demod, xt, and all these constants which you will put here. Then you will plot the demodulated signal. At the end, you will get like this. This my message signal, then my this my carrier message, and then here this is my transmitted signal, and then at the end you will get your received signal. This is almost equal to this. Okay. So this will happen only with one command. No mathematics required for this. Only demod. But these you have to define yourself. Okay. So it's difficult or easy? Mixed. Yes, because a lot of mathematics is involved. But I wanted to give you a background knowledge for this because you didn't cover this topic in the class. So, okay, let's start. I have uploaded this examples on Moodle. Did you check that? Lab 6? So for today, today's submission of the assessment, if you will tell everything in detail, that okay, this is my message, this is my career, here I am scaling the scale axis, then I will increase your grade for the previous lab. Okay, if you get 10 by 10 in lab 5, then I will increase. Okay, for all the people who were telling me that grade is not good, so you have the opportunity to change them by submitting your lab file. Abdullah, you have good grades? All of them?
Not sure. Yeah, I put comments.
Yes, you were. Okay. Then I think yours is, because I don't remember. So let's start this. Go to Moodle. Matt, you want online? Do you remember your physics? But it's okay. Do in the not
This is not the opening view.
it's not okay.
No, it says it needs some updates for classes. So we're trying to update. I downloaded the file.
Maybe there is something with the PC. I don't know. I think with the one also is the same problem. Yes. Do you have online? Do you have online?
Yeah, it's on.
Sorry, the one you don't. You don't remember your. Maybe try another PC because I think they are installing here. Maybe try this. Because in my PC it's good. Try one by one. So if you remember your online ACSC ID and password, then you can make it. When you will solve these mathematical equations yourself at home, then you will understand. It's only trigonometric identities. I think in questions you will need it in the exam.
S1E4.
1E4 means 1 into 10 raised to the power 4.
Exponential, right?
No, exponent means power.
Yeah.
Yes, 10,000.
Oh,
You can just write 10,000 or 1e power 4. It's working there. I don't know what they did with try all of them. I try to remember your password. Reset. What do you know your email? Email password. Email password. So for the online students, I will check your work. So, and also I want to ask you, did you understand today's lab? Yes. Okay, Arij. So for all of you, I announce that if you submit your lab perfectly well with all the comments, I want to see that you are understanding. Whenever you are writing some command, for example, if you ask me, what is this? I can say that, okay, this is my message frequency. Frequency of message signal. So this kind of comments I want from you. Okay, so that you understand everything.
Doctor, the previous labs, I don't write comment and you put for me 6 from 10 and 7 from 10.
-2 I did for comments, but I gave you the opportunity to increase that 2 marks if you submit today's lab perfectly. I gave all, this is for all the class, not only to one student. For today's lab, and then no copy paste. Because I understand when I see copy paste, then I know that this solution is copied. Okay. I will give you +2 marks in all the previous labs if you today's assessment is perfect. Okay.
I must submit today.
Yes, today we have the deadline for the lab 5.
Listen, I can download the file. I can't because that's 10 minutes. The exam, so I don't know the.
You can upload it. You can upload it on.
I'm sorry now. Not sure how much is that.
1 minute. You can upload here. This is the online.
Yeah. Can I?
Yes, yes. From downloads. Down. Where did you? Yeah. And then upload. Remember your password. That's the DSP. It opened? Good. Now, did you download the I think it will be the same.
So here, just you put the message signal frequency.
Yes.
35.
Yes, 35 hertz. Yes. It's given here, 35. Frequency of message is 35 hertz.
And the one that you put E to the power something.
That is sampling 10 kilohertz. 10 kilo, 10,000.
Oh, yeah, that's fine.
10,000. So all the data is here. Lab 6. Lab 6. No. This is the one here. Maybe yes. So when you're doing all these equations in the class, you see by solving all the derivations.
Yeah.
Okay. So she will do all the derivations. But you can do the derivations yourself also.
Yes, she usually that's what the mathematical.
Yes.
major.
Can we say the plot and the column?
Yeah. Other one. Here you will define your.
I did this on.
You did this one.
Yeah.
Okay. So plot this.
Yeah.
Yeah. The result is this.
No, I know the result. I mean the plot. Yeah.
Okay. With in time domain, all the plots is in time domain. Okay. That's right. S3 M. So only the time scale and sampling frequency. So are you guys done online? Khadija? Khadija? If you are mute, okay. Khadija, can you share me your screen? Khadija, can you share me your screen? Done. Now this one. Okay. Okay, now Khadija, you can share your screen. Okay. Okay, can you yes, unrecognized variable LE4. This is one. This one. It's Fs is equal to 1, not L. 1 e raised to power 4. Fs, yes, this 1. Yes. And then you have to put in power. Okay. It works. And then you didn't, okay. So you didn't plot this C and AMM and then XT. You have to plot C and then M and then XT. C is carrier, M is message. So, okay. Perfect, you really did a good job. But here, you have to plot them. If you put here, plot C with T and then
Mr. You put the file for that stick.
not yet. Which file?
We did a file.
These slides?
Yeah.
I didn't. I can put it now if you want. You want?
Yeah.
Okay. 1 minute. Okay. This should be T with C. T and then so yes, Masir, Khadija, you can do it yourself. So T first X's will come and then okay. See, this is fine now. Write T and M. So this plot I want. Okay, change it. Sorry. KFM. Okay, it's up to you. If you want small, then all everywhere it should be small. What happened? Yes, this is fine now. Okay. So now I will upload. Okay, I stopped sharing your screen. I will post this on Moodle. Okay. So now slides are here. Okay. Not this one. Another one. It's left. Okay. What is happening here? So now, Masira. Masira.
Yes, miss, with you.
Yes, okay. Did you solve your classwork example?
Miss, now I'm trying, but wait 10 minutes, please.
Okay.
Miss, and I need to tell you about my friend Fatma Fahad. She have a midterm makeup. That's why she don't attend.
Okay, she couldn't attend. Okay.
Hmm.
So your section is fine. I have to check your because from the Zoom I will get the attendance, which will be like if someone is not joining on the Zoom, so attendance will be according to that Zoom presence. So I can take manual. So okay, Reem is here. Reem is here? No. Yusuf. Yusuf Al-Awal. Ilaf. Ilaf is here, I think. Ilaf, are you here?
Yes.
Oh, sorry. Okay. Fatima. Fatima, Masira, are you talking about Fatima Ahmad?
No, Fatma Fahad Naif.
Fatima Ahmad is here. Fatima.
See the chat, miss.
Fatima Hadi. Okay, yes. Anwar.
I'm
Anwar.
here. Yes.
Muhammad Ali. Muhammad Ali. Muhammad Al-Inazi. Absent. Abdullah Mansoor. Dari Muhammad. So Dari is going above 12%. Asma. Asma is here. Arij. Arij is
Yes,
here.
I'm here, miss.
Reach here.
Yes, okay. Taiba. Taiba is not here. Nawal. Nawal is here. Hiba. Hiba is not here. Fatima Yaqub.
Yes.
Okay. Khadija is here. Fawaz Saud. Not. Taiba Joda. Abdullah, it's you.
I can't see from here. But one more.
191397.
No,
Abdullah A.S. Abu Amara.
yeah, that's it.
That's you. Okay. Masira is here. Fatima Fahad.
Yes, this is my friend.
Wail. Wail Said. Abdul Hadi. Okay. Ahmad. Ahmad Said. But I think some of the students have
Yes, miss.
Ahmad.
Yes.
Amina. Amina is absent today. But if some students were in the exam, they can come to me. I can change their absence. Okay. So this student is going away. Like he is in right now. Okay. So, Ahmad Said, can you show me your screen? Ahmad.
Miss, I get zone in my phone. If you wait.
Okay. So do you have any questions from today?
So demodulate, is that a command?
Yes. Yes.
So it multiply with the same carrier?
Yes, it will actually here you are putting this XP that signal from here. This is your modulated signal. Previously, what we were doing, we were just multiplying carrier with the
And then on the receiver set, the receiver end, we will multiply again with the same.
again with the carrier and then get the original.
So this.
Here we use this command. Yes. Here we use this command, but we have to put all these constants here, and then we will analyze this. We don't have to manually multiply it. In low pass filtering. There we use the filter option, butter filter.
Yeah,
Yes, but here we are not doing, everything is done using this.
so it will multiply and it will
Pass
pass it
on
through the
pass
filter,
it
so I will get
through
the
and then,
related signal.
yes, you will get the
Original message signal.
estimated message.
That's the part.
Yes. But in the modulation, you don't have mod. If you put mod, then it will take the modulus.
You mean from the transmitter end,
Yes, at the transmitter, this only one
I have to
command.
multiply it as
Yes.
it is.
Here, this is at the transmitter side. Sorry, this is at the receiver side.
Yeah.
Here at the receiver, you just use
Yeah,
here.
I was talking about that I can't use it on the transmitter side. I have to multiply it manually. It's easy.
At the transmitter side.
And just multiplication, create the,
If you multiply what you want to multiply it with this modulated signal.
yeah, like
Okay.
So this command is actually doing the multiplication of the carrier and passing it to
And the same thing as we were doing, but there we have to
Yeah.
Here this is P for the frequency. I think for the amplitude it's not possible. That was amplitude.
Oh.
Yeah. I think for the amplitude not. I don't know. I didn't say. But maybe not.
Yeah. Yeah, I didn't think about it like that.
Yeah, because everything.
We will see which
Yeah.
can be done manually or not.
We try to lie the information. We try to solve this video. Then you will get the answer, you will understand. I tried to put all the background for the lecture also, so that you can understand it. Okay? Done? Did you understand? You have understood? No. You got this
Yes.
easy? I think this is easier than amplitude modeling.
Yes.
Yeah,
Here you don't
I
have.
agree.
Yeah. Here you have
And
this.
we're not going to the frequency. domain, right?
No,
don't
we are
have
not.
the 40.
We can plot in frequency domain, but it's already we are dealing with frequency.
Yeah, I
So
know, but since DMOD is there, so
so we don't have.
yeah, we don't have.
So directly we are getting the same signal. No. Okay. I think it will save in your mind. So you don't have to send. So what's your name?
Pardon.
Fatima? So it's you will do your assessment today.
Yes.
I will remove it and I'll do again.
You have the time. Until which time?
And
12, I think, yes. So if you will do it, then I will give you +2 in the previous lab.
When will you upload the assessment?
I will upload it after this class.
Okay.
Yes, Arij. Yes, Arij. Using class this one must be single input of file values. So here. Okay. So here you are putting 2. So here only this is P again. Remove this. Yes.
Okay, thank you.
So those who have already submitted your assessment file, they can re-upload it. They can remove the file and upload it again, so that if you want to change something, so you have the chance until 12 today. Okay.
Miss, we submit the lab assessment
Lab 5 or 6.
for this lab.
This lab, I will give you 4 days. 4 days is the deadline, because this week you are free. Yes, you are like done with your midterm, everything. So you are free. 4 days is enough? Yes, Abdullah, 4 days is enough?
Yeah.
Yes. Okay. It's the same like examples. It will be the same. Okay. So, okay. So, if you are done, all of you here online. So this is it for today. Abdullah, everything is clear? Clear? You have done it?
Yeah.
You're solving, okay, you're not solving the assessment. I didn't upload it. So, okay. This is it for today. And then please upload your assessment 5 today, because the deadline is today, and then try to change it. Try to cover it like my feedback comments. Okay. Try to.
Thank you, Miss.
From others. If you will copy, then again I will deduct the marks. Okay. Okay. So this is it. Okay, I need the phone.